Okay, I think we'll just get started.
That's my thing, is to figure out how the tricks can be used to hold.
Okay, guys, we start. The purpose of this recitation session is get you guys familiar with context-free grammar, which I think is easy, but I don't know for the rest of the guys. Yeah, well, we'll just go through some examples and show that what can be done easily, and for certain problems, there's some ways to do it. So the first example is the language that starts with something and ends with something. So here we assume the alphabet is only 0 and 1. And when you see the problem of starting and end with something, you should be happy. Because what's a context-free grammar? What can it do? First, it has a start state. And then it corresponds, you can generate certain things. One of the things is symbols, right? For example, 1. And it can generate some variables. And to the right or left of the variables, it can also generate something else, like symbols or variables. So this is one example of context-free grammar, right? And what else can it do? It can do a disjunction over another expressions. And what does this variable represent? It's up to you to define. So here, as long as you define the right variable, then you're done, because you can easily control the first and last elements of a string using context-free grammar. And the same reason you can control the first element or the last element. So in this example, we'll say that it's start and end with the same symbol, and X is arbitrary strings can be constructed using 0 and 1. How do you do that? Basically, X is arbitrary string, right? So it can be this, it can be this, it can be this, it can be this. That covers all the possibilities. What does it say? An arbitrary X, it can start or end with 0, or start and end with 1. Yes?
Since X is in the middle of the start string there?
Yes?
So the first rule says you start with 1, you have an X in the middle, and then you end with 1, or with zeros.
Right. The first rule says it must start and end with the same symbol, and X is an arbitrary string.
So then couldn't X just be 0 or 1 or...
Oh, sorry, it can be empty string, yes.
What about the string like 1 or the string 0? Just one symbol.
That's a good one. Sorry. You guys are right. Special cases. That looks all right. So this is the general cases and some special cases. Or you can simplify it a little bit by writing this. Say S is, say, arbitrary string A. Instead of writing 0, 1, 0, 1, you can use the variable to represent either 0 or 1. That's kind of simplification. But essentially the idea is the same. Yes, Moody.
So we can replace the first line in the second version.
Right, you can replace the first version with the second
I
version.
mean, instead of 0 and 1, you can say
You can define a variable that represents either 0 or 1, and then use a variable instead.
No, you know where you say S is AXA or 0 or 1?
Yes.
You can replace 0 or 1 with A.
Oh, true. Yes, that's correct. Yes.
On that, the second row, no, yeah. Do you have to have the 0x and the x0?
Because it can occur in the beginning or at the end.
That allows it to recurse, to have an arbitrarily long
Right.
string, right?
Yeah,
Right.
if you had 0x,
Uh-huh.
then you wanted to add another 0 or another 1 to it, you could.
No, but this only adds zeros at the beginning. Let's see. Maybe, so you're saying you can simply write 0x or 1x. That might be,
What string won't work with that?
that might be one choice. Let's see.
0, 1, 1, or
Yeah, it generates arbitrary. It looks to me they generate arbitrary. Unless you guys find any counterexample.
if they don't find the counterexample, can I have some extra points in my test?
We're done with the test.
All right.
On the bottom, does A need to have epsilon now?
Here A? No, A represent arbitrary alphabets.
Okay, yeah, I see it.
Yeah. So here maybe we can remove one term. That make it a lot simpler. And
You're required to simplify it on the test, or
no, as long
valid
as,
grammar is a valid grammar.
yeah, valid grammar is valid grammar.
For the second set, or for the second S,
Yes.
if you replace the X with an S, is that still valid?
Replace X with what? With S?
No, the X above it. For S is AXA, you make it ASA.
Oh, like this.
Does that work?
Let's check, I don't know.
And then A is still 0, 1.
Okay. So you guys see how difficult my work is. This always generate even number, but this can make it an odd number.
That would generate palindromes, wouldn't it?
Yeah, it will generate palindrome. Thank you, ma'am. Okay, so you see how to generate arbitrary string, how to generate the string that you can control the start and end. Let's do something else. The length. Okay, how do we count the length and the middle symbol?
Can the generate palindrome because the starting A can be 0 and ending A can be 1.
Sorry, no. Actually, Tanya is right. The A does not have to be the same.
Can A have two values?
The 2A does not have to be the same symbol.
But if it's not mentioned the
Within a
same
given
symbol,
rule, they don't
in that case, it's not. Okay.
Actually, the string generation is like this. So first we from S we generate ASA, and for A we look at the definition of A. So here for this A we can either choose 0 or 1. For this A we can either choose 0 or 1. They don't need to be the same. The same variable just means that they use the same generation rule.
Okay, please right. The previous you answered cannot.
Yeah, it does not necessarily generate palindrome.
This is, so you're saying this is just to make sure it's odd?
No.
Back to the first problem.
Yeah.
Back to the first problem. Sorry.
So that start simple rule is wrong because it should say you have to enumerate the possibilities 1S1 or 0S0. Those A's can be arbitrary, right?
Right. Oh crap. Sorry guys, back to the first problem. This is wrong. This is wrong.
Why is the happen there?
Because A could be 0 and then A could be 1.
Right, the two A's does not need to be the same symbol. That's why. Okay. Back to here. Is this one correct? No, it's not.
Do we need to have 0 A's?
Yeah, this is not. We have to do the X thing.
1 or 0?
1 or 0. This should be the one. We cannot replace S here because well, because this A can be arbitrary. But if we do this one, it's still not correct because that will only generate palindromes. That's why we have to switch to this version.
What was wrong with the grammar when we replaced the zeros with the A? The one before we replaced the S.
But for this one?
We had the A, X, and A.
The 2A does not need to be the same. Then it does not generate the string that start and end with the same symbol. Okay, not an easy problem, right? Are we done with this one? Okay, now the length. We cannot control arbitrary length, but for the length, the even or odd lengths, we can still have some control. Basically, from S, if we keep generating two symbols, this will be even length. this grammar keeps, so if we apply this rule, it only generates even number of symbols. And yeah, I is saying as before. Then what's an odd?
What about zero at the beginning?
At a 0?
Yes.
No, then it can generate either even or odd.
Yes, 1 0 is the odd number. And
Oh, sorry, we're not at the second problem yet. We're just trying to write the context-free grammar that generate even number of. So now S stands for even length strings. What's odd length strings? You just add at least one symbol to S, right? So let's name this variable odd. That means AS, what? SA, right? So if it's even number, then add one letter to it. That will be all lengths, right? Everybody follows.
This way, we can, for odd length, we can remove the epsilon in the definition of this and replace it with an A.
That's also true, yes.
Say that again?
Remove this epsilon. Basically, the termination condition. You say that the termination has to be at least one letter.
Why?
Because the first half says it generate besides S, it generate even number of letters.
This is for odd now.
Right, this is for odd.
Gotcha.
Yeah, either I would say either way works, or whatever that fits. So you can generate even length string, odd length string. And the second problem just asks for one extra, which says the middle symbol is 0. So what's the middle symbol? Is this one, right? Do you see that?
Yeah.
Because S will keep generating the letters on the side. And when it terminates, it has to terminate in the middle. Right? So you just replace this with 0. That will be the answer. Everybody follow? Matt?
Can A also be the empty string?
I cannot, because if you allows empty string, then you basically changing the length here.
Oh, because then you could have one on one side and one not on the other side.
Right.
Okay.
Clear? Okay, empty set. What kind of grammar generate empty set? A tricky question.
Epsilon.
Start with epsilon. Is it empty? No, right? Moody?
I think we can make any, like say A is 0 or 1, and then S points to nothing.
S to B, something like that.
There's no rule for S, right?
Okay, no rule for that.
So a context-free grammar, you define the alphabet, you define the start state. If there's no rule for the start state, then basically it does not generate anything. So first you tell me what's the start state, and you say explicitly there's no rule for it. Then it does not generate anything. If you simply write this, I might be confused that I might be the start state.
So then we just leave it blank, the question blank?
Well, you can explain in words more detail. Yeah, you define the alphabet and you define the start state, and you say there's no rule for it.
All about S, arrow, and nothing.
S arrow nothing. I don't think that's the valid grammar. Is it? We have to double check the definition of grammar, but I don't think that's.
Leave blank is it's not allowed to test. So.
You just write it. There's no rule. Are we clear? Okay, fourth problem. I leave it to you. You want to try? So basically, you only generate string at most length 1.
Oh, wait. I have to put an S here.
Okay. Can you explain?
Okay, so basically, you recursively get zeros or ones,
Okay.
and at some point you need to add.
But how do you count the number of ones or zeros?
So. Right. Never mind.
Sure.
So S can recursively grow in either direction, and anytime you add a 0, you also have to add a 1, so you always have more 1s than 0s, or at least the same, and then eventually S needs to be a 1.
That's A, right? So basically you require 0 and 1 has to stick together.
Yeah. So that could be
Sure.
I don't know how to fix it. That's not gonna work either. Never mind.
No, sorry. Any more ideas? Sure. explain? And your name?
That's That's difficult to explain.
So basically, what's the meaning of X? X generate only ones.
Yeah, so either you can have a 0 and a 1, or a 1 and a 0, or both ones. You can also have a 1, which is also a valid string in the language. And then you can expand X as 1X or X1 or an empty set.
But
So
here you,
every time you make sure you have more ones than zeros.
Our strings can only have 1 0 here though, right?
Yeah.
can't
No, but then
reverse
we can.
We can't make more
yeah,
zeros.
yeah, yes, yes.
You can't start and end with a 0 either.
Yeah.
True.
basically in here you,
Yeah.
you restrict. It's okay, take your time.
Is there a way to think about these, or have you just done a million of them that you know where it's going?
There's a way.
There. Tell me the secret.
Okay, I'll give you hints first. The set of string that has more ones than zeros, right? So, how do you divide it recursively?
I was trying to figure out a string that has equal amount of ones and zeros, and then one more rule on top of that that adds an extra one.
That's the right direction.
But that's where it's
You always have to come back to the 1, so you can go to 0. When you go to 0, you always have to go back to that 1.
Even zero?
Right? So you start at the 1. Can I?
Sure.
Is that, am I on the right track with that notion?
Was it?
Am I on the right track with that?
Can you repeat?
If you start with the 1 here, you
Okay.
go to the 0, you always have to go back to the 1 to put the 1 in, and then you can end on the epsilon down here.
But this, that might work. I'm not sure.
You're not sure?
That's not the one I have in mind, but it might work.
Okay.
Just go ahead and write it down.
All right.
We'll see.
How about this one?
Sure. Oh, just this?
Yeah.
Just first line. So it does not start and end with 0. Sorry, but it does not start with 0 and end with 0 at the same time.
Oh, which one?
What about 0, 1, 1, 1, 0?
Oh, it won't. 0, 1, 1.
You cannot generate.
0 plus 1.
And epsilon.
Oh, yeah.
You can't start
From that step, you're done. Yeah, from that first step.
Right. We have another solution, Jeff?
It's a shot. I don't know if it's a solution.
Okay. Can you explain what's the idea?
Well, you start it on at S, and you could go down. Oh, it's not going to work.
Yeah, well, there's the same counterexample there, right? 0, 1, 1, 1, 0.
Well, I guess you'll have to add a couple of 4s and have it could also go to 1S.
I say that's pretty close.
Yeah.
Let me give you guys my idea, and I don't finish. You continue. A string that's more ones than zeros. It can always be splitted into. Is that necessary? is either, let's say X stands for even number. Sorry. X stands for at least, okay, let's do it easy way. The number of 1 is greater than or equal to 0. So it's either in this way, or this way, or this way. Is that true? There's nothing else. Matt.
Couldn't, if X only had, if the only restriction on X is that it has greater than 0 ones, couldn't X be 1 0 0 0 0?
Sorry, X means the number of ones is greater than or equal to the number of zeros.
Oh, okay.
Yeah, you're right.
Isn't that the original problem?
No, the original problem is more ones than zeros. You downgraded one level.
Okay.
One is strict greater than, and this one is maybe greater than.
How do you write the rule for that?
Maybe greater than? That's a good question. So what's the maybe greater than? It's either I suspect it can be simplified, but let's first do it in this way. So whenever you have a 1, then you must have a 0. And for the rest of the string, is it necessary? No. Sorry, that's wrong. Because you can have all the 1s here and all the 0s here. You can still do. Where's the partition? This is 1x. This is 1x. This is 1x. Okay. So whenever you have a 0, you must have a 1. And for the beginning or after, well, in between, so assume that the string starts with 0 and ends with 1. Then in between, it must have at least the same number of zeros in 1. Sorry, number of 1 must be at least the same as the number of zeros. Okay, I know how to simplify this. First is the string that starts with 0 and ends with 1. Then this is the case. Second is a string that starts with 1 and with 0. What about the string that start with 0 and end with 0? Then there must be more ones than zeros in between. For the one that start with 1 and end with 1, no, this will make it more complex. Okay, so what's the case? Let's start with 0 and end with 0. Then there must be something like this. There must be at least 2 ones inside. And for the one that start with 1 and end with 1, it could be 1 zeros here. There are 2 cases. Let's see whether this is correct. So this is clear. For the one that start and end with 0, there must be 2 ones inside. And rest of the string, there must be even number of, the number of 1 must be greater than or equal to the number of zeros. And for the ones that start with 1 and end with 1, the 2 cases. One is the same number of 1 and zeros, or we allow at least at least 1 0. We allow 1 0 or 2 zeros. That doesn't look like a nice answer. And epsilon.
Why do we need those special cases for strings starting and ending with 1?
Start and end with 1s.
I mean, why do we need a 0?
This one.
Yeah.
Because this one contains only so for example 101. We have to somehow say that the string in between has more zeros than 1s. Yeah, this is very ugly. Yes, Madi.
Why do we need the last one before the epsilon?
This one, right?
No, right after. Yeah.
This one?
Why do we need this since we have the one right above it?
Because, for example, 1001.
Isn't that possible to do one?
It's not possible to here. Not possible to anywhere, actually.
But then, oh, okay.
Yeah, I don't like it. Let's find a different answer.
How would you get 101?
It's here.
But it starts from S, right? So it always has another 1.
Sorry, what's that?
If you just list just the string 1, 0, 1 from S.
Oh, from S.
1x.
1x 0, 1. But it's way too complex. There should be an easy way. Let's see.
Sounds easy.
Here's the easy one.
Okay, great, good, Jeff. That's nice. Can you guys see it? Oh, it's too dark.
Oh, it's supposed to be next, sorry.
This one?
That's the next.
Can you explain your idea?
No.
Okay. For the string that has the number of ones greater than or equal to the number of zeros can always be split into two strings that has the same property. Why is always? That's what this one says. Why is it always? Because in the extreme case, this is one x, and the empty string is the other x. So you can always split. And for this one, it must start with, so if it has a 0, then it must have a 1. Why this one covers this case? Because first you can split this. And for this one is one x, and this one's the other x. Okay, let me do it this way. For the string that has more ones than zeros, there are still 4 cases. One is it start with 0 and end with 1. Then this is the case. And the other is it start with 1 and end with 0. This is the case. That one that start with 0 and end with 0, since we know that at the beginning there's 1, 0 and the end is 1, 0, then we can split the string into two, where the first half contains more ones, more or greater than or equal to, what would I say? Where the first string has the same number of 0 and 1s, and second string has the same number of 0 1s. Do you understand this part? Why? Because this whole string has more number of has at least, so the number of ones is greater than or equal to the number of zeros. And we know that there are 2 zeros here at the beginning and at the end. So the inside string, the must contains more ones than zeros, and at least 2 more. Right? So we split the string. So if it's 1, 1, then we split. So we distribute 1, 1 here and the other one here. That will make the two string to be having the same property. That's why Jeff wrote x split to xx. That corresponds to this case. And for the one that starts with 1 and ends with 1, we can always remove. So first split into 2 and remove a 1. And the rest of the strings will still have the property that contains more 1s than zeros. I think you start to lose from here. Where do you want me to go back? Here. Here. Okay, the first two cases are clear, right? The third case, that start and end with 0. Then this string can be split into 2 strings. And each of the string has